Plastic evaluation is our core expertise at Gradical. We help medical technology companies choose the right plastic for their application with the technical suitability, regulatory compliance, and improved sustainability. Learn more under www.gradical.ch/plastic-evaluation. Our guest today is Jonathan Demierre. Jonathan is an expert for eco-design and leads the sustainable engineering team at Helbling. He holds a PhD in energy systems from the EPFL Lausanne and worked at the Sustainable Engineering Lab of Columbia University in New York. This before joining Helbling Technik. His whole career is centered around sustainability and eco-design. Here is our discussion. Hi, Jonathan, and welcome to the podcast. You are an expert in eco-design. What is eco-design and how does one do it?
Hi, Lucas. Thank you for having me today. It's a pleasure to be here. So let's talk about eco-design. What is eco-design? So actually, it's simpler, I would say, to define as what one can think. So eco-design is actually the process of developing products and systems while taking into account the environmental impact of the design decision. When designing a product, you go with one or the other variants, and because you want to balance the different design goals. So in general design, it can be the cost you want to balance with the performance or with the convenience for the user, and so on. So for example, so you will go with housing in metal for your laptop if you want to have a design with a premium look. And on the other way, if you put more importance to the cost and you want to lower the cost, instead of metal housing for your laptop, you will design, for example, a plastic housing. And for eco-design, it's actually exactly the same. It's just that you use other or additional criteria like environmental impact. So environmental impact can be the consumption of water, of course, the carbon footprint. Today we hear this the carbon footprint a lot, and you include that actually in the design process. So basically, it's quite simple.
So it's actually just designing with sustainability or ecology in mind.
Yeah. And in the future, I hope we will even no more call that eco-design, but again, just design, because I think how things will evolve is that it will become a standard to do eco-design. And I guess we will not call it anymore eco-design. Mm-hmm. So on the definition, it's quite simple. Then to apply it, and then it's today still quite challenging.
Okay. So you take into account the ecological footprint of your materials, processes that you use to produce your product. And which are the most important metrics? You mentioned carbon footprint and water. Are there other metrics that you would take into consideration for producing a medical device?
Yeah, so this is actually the challenge. So today there's still a lot of metrics. But now to say a bit simple, and the things that interest the most, or what we see in our project, the medtech industry, is mostly, of course, the carbon footprint, something that also like to use as metrics is the waste that you generate, especially the unrecoverable waste. So typically the plastic that cannot be recycled, that needs to be incinerated or landfilled. There are also other metrics that are used, of course, water. And something that also tends to become more and more important is some kind of measure of circularity. And for this, so how much actually you use secondary product flows, so actually recycled material, and how much of the waste that you generate can be looped back into the system, so as a recycled material to be used either by in your product or in product of others. And for this, there are different metrics to measure this kind of fitness to the circular economy.
Okay.
And
because that's very interesting, because my design thinking in when supporting someone in choosing a sustainable material is you have impacts on the environment from your product. For example, carbon footprint, or if you use a bio-based plastic, you have to take into account land use, you have to account for fertilizer use, water use, stuff like that. And then I always tell my customers, take the material with a reasonable price and the best sustainability or eco footprint that you can find. And sometimes that's a circular product, so a recycled plastic, but sometimes it's also not, because recycled plastics can come from different recycling processes, like mechanical recycling or solvent-based recycling, or even chemical recycling. And with chemical recycling, that's a big, let's say, controversy. Is it really better for the environment or not? Because you use a lot of energy. And the carbon footprint of some chemical recycled plastics can be quite high, although they're completely coming from circular sources. That's a little difficult to take that into account. But maybe you could go a little more into detail how you would measure the circularity and the argument for why circularity is so important.
so we like usually to check to take into consideration two metrics at least. One is the carbon footprint, and the other one is the circularity, and how the circularity is measured. So one metrics or one number that it's used often is the material circularity indicators. These have been defined by the Ellen MacArthur Foundation and the World Business Council for Sustainable Development. And this is used by a few companies. And it's kind of material flow efficiency that looks at how much actually secondary flow or secondary material, how much recycled material you use, and how much you give back as a recycled material. Of course, here you don't have the energy that is taken into account for the recycling process. So you will not differentiate what is a mechanical recycling and mechanical recycling. This is why we liked also to couple that, to use also the carbon footprint to see the difference, because as you mentioned before, mechanical recycling use much less energy than chemical recycling.
Yes.
And so why today it's important also to look at the circularity is that the energy mix is changing. So almost everywhere in the world, we are decarbonizing the energy mix, and especially the electricity mix. So this means that chemical recycling, even if today these are not so much interesting into in comparison of carbon footprint to the actual material, is because you need a lot of energy, and this energy has a high carbon. But when we will be able to use as energy source for the chemical recycling solar thermal energy and renewable electricity, then it will change also the carbon footprint of those chemically recycled material. And another important point is the resources that you use. This is chemical recycling comes with the thinking that at what point in time the raw material, so oil, will come a bit shorter. And this we discussed about the end of oil reserves since decades. But I mean, it will come sooner or later. So we will end up with with the needs for chemical recycling or other source of where we can renew the raw material.
Yeah, sure. And you know, I like to be agnostic about the feedstock of the material, and just focus on the environmental impact, because you could also look into other feedstocks than just chemical recycling or recycling materials. such as bio-based, or I mean, carbon capture is still, let's say, in the future. It's in its childhood technologically. You cannot do carbon capture on a industrial scale yet. So that is what I like about my approach, to just look at the environmental footprint and not at like recycling rate or circularity, because it is a little more agnostic to where the feedstock is coming from. You could also use carbon capture or bio-based if it's better in the carbon land use, water use, energy use departments, instead of recycling materials. Or what do you think about this?
Yeah, thank you for this this remark. This is very important, and that goes beyond just the topic of the source, the resource for plastic. So I fully agree. Being agnostic, this is the right way, because in the sustainability thinking, especially in eco design, we are confusing sometimes what are the means and what is the goal. The goal is sustainability, and whether it is with recycling, mechanical recycling, bio-based, those are just means. Those are just way to achieve a goal, where the goal is sustainability. So actually, we should not think too much about the technical aspect, but and not compare. Actually, it makes no point to compare, to say one solution is better because it's mechanical, or because it's chemical, or because it's bio-based. What you want to see is compare the impact on the environment. And today, I mean, we have to know that this is the case, that there is a mix in the sustainability discussion, a mix between the ultimate goals and the means. And sometimes that's also what we see, that sometimes companies put goals on means. I mean, they should have as goal reduce the carbon footprint, and they somehow break that down to we should use more recycled material. I mean, it's good because it gives already technological direction to the development team or to the R&D, but it is also dangerous because it locks you into specific technologies.
Yes.
And it's you will not be able then as R&D to open up the whole the whole spectrum of solutions.
Yes. And not only companies do that, they do not tell their R&D department, reduce my carbon footprint by 30%. They tell them just, yeah, by then use this much recycled material. And this is not only companies that do that, but also governments, and just governments mandating certain kinds of recycling quotas for certain applications. And I mean, this would be probably a good time to go into sustainability or eco design requirements that are coming from these regulation. And there's actually an eco design regulation that is coming out from the EU. It's, as I understood, not finally published, but I think it's quite fixed what it's going to look like. Can you tell us a little bit about that? Credical is the plastic expert in medical technology and supports you in the areas of sustainable plastics and material compliance. Our course, Sustainable Plastics in Medical Technology, will bring your development team up to date with the latest developments in sustainable plastics. In addition, we offer the course Regulatory Aspects of Plastic Selection at the CATS and the SCATZ, which provides guidance through the maze of regulations when selecting materials. More under www.credical.ch.
Yeah, so I guess you are mentioning the eco design for sustainable product regulations, so that have been adopted, if I remember correctly, for a couple of months ago, and which will be that enters into force so in June, July this year. So here the goal actually it's the kind of the brother of or the sister of the regulation, the eco design regulation. So this eco design regulation, we knew that well. So this is the one of the energy label with the different class A, B, C, D, and in this regulation, there were also some topics about use of material and about repairability. But so what is new with the new regulation, so ESPR, is that here, for example, it's really a goal to optimize the product and to be transparent on the carbon footprint and the environmental impact of the product. So this is one first thing. Second thing, it's the aspect of circularity. So there will be clear regulation or clear requirements regarding the presence of substance that inhibit the circularity. So like additives in plastics that usually impede the recycling of the main plastic. And a third thing also linked to circularity is the topic of upgradability, reusability, remanufacturing of product. And as fourth point, so maybe one of the most important is also what many have already heard about, is the digital product passport. So today, so the regulation that have been accepted and entered into force at the beginning of the summer, so it gives actually general directions to which the different industry sectors will need to develop more precise requirements. And today, so we don't know where this will head exactly. What we know today is that the first industry that will likely publish clear requirements, it's the textile industry and the steel industry. And then after that, so this will be in mid 2027, how it is planned today. And then after that, it will progressively be also extended, and all industry will elaborate their own requirements. This is the so-called Delegated Act, and it will come with electronics product, with medical products. So after 2027, so it's to be expected in 5 to 10 years horizon.
Okay, good. So to summarize, it basically gives requirements for the sustainable for product development in a sustainable way. You have to number one, measure your carbon footprint of your product and make that a clear product information. So make it available to your customers. Then secondly, you have to have information on circularity, how much recycled products you use, how you would recycle your product, a digital product passport, and then you have requirements to reusability and repairability and stuff like that. How about, there are lots and lots of single-use medical devices. How about single-use devices?
Yeah, single-use devices. So they will have to find their way into the concept of circular economy. So here, this is a bit the unknown how things will be solved. So one way that I see is to go more into direction of chemical recycling. We know today, so in terms of energy efficiency, in terms of carbon footprint, is not ideal, but there is improvement potential for sure. This will solve the issue of hygiene with chemical recycling, since you go really back to the naphtha, to the raw material, which is close to the oil product. Because we need to mention that all the single-use product, they are not single-use just for fun. So on one side, we have single-use product because it's convenient, and this we can imagine to either replace part of those products by reusable product. It can be a bit complex in terms of logistics, but this is something that we can imagine. You see that already with plastic bags or with straw, plastic straw. Then we can imagine for the products, single-use products that are not, where there is no hygiene issue, use mechanical recycling. And as mentioned before, so for typically what you have in the medical industry, the product that are single-use because they are hygiene issue, here I don't see today any other way to implement circular economy than chemical recycling.
Okay, so two inputs at that point. As number one, you used my trigger words, and that is the plastic straw. I completely oppose the paper straws because they're thicker. They use PFAS, and their environmental footprint is actually bigger than the plastic straw. So the best straw is actually to have no straw, to just drink your drink without a straw. And then the second best is a single-use plastic straw made from sustainable plastics, such as bio-based or recycled plastics. But actually, if you use something else like paper, just to get rid of the plastic, because plastic is obviously evil, it's actually not, increases the environmental footprint. So that's the fear that I have, that you put goals on means, and then you go ahead and increase the environmental footprint just to comply with the means. Because I've looked into this, like the reworking and the remanufacturing of medical devices. And if you have single-use devices that are very expensive, a heart catheter or something like that, there's actually a company that remanufactures these. They call it remanufacturing. It's actually, they re-sterilize, they clean everything, they test it again, and then you can use a heart catheter, class 3 device. You can reuse that. It's called, the company is called Vanguard in Germany, and they do this. The device costs, like originally it's like 2,000 euros something, and they can offer that for like half the price, which is very attractive to hospitals because they save on cost, and the sustainability footprint is very good. So they have half the carbon footprint of the original device, which is great. And then you have like very, very cheap single-use devices, syringes or stuff like that. So a blood syringe, to re-sterilize that, the cost would exceed the production cost of the syringe, number one. And secondly, you couldn't even save on environmental footprint, because steam sterilizing such a plastic device usually uses more energy than producing the plastic device in the first place. So single-use devices have their place, I think. We can save on sustainability with very expensive devices, and there are throwaway devices that don't need to be thrown away. Don't get me wrong, we can do better. But there are devices where there's just no environmental savings there. And just to make it reusable because it is reusable and not because it saves environmental footprint, I do oppose it. And this is very important in the eco design. A lot of people work with heuristics. So if I have recycled plastic in there, it's better for the environment. Or if I use reusable products, it's better for the environment. But actually what you should do, and maybe you can elaborate on how to do that, is do a life cycle analysis between two cases and then compare the outcomes. And this is how you would actually go about designing a sustainable product. You can go into the details of how you would elaborate on how you would design such a sustainable device.
Yeah, exactly. This is a very important point. What you say, we see that too much. So exactly. So products that are developed or strategies that are developed on heuristics and without thinking of the goal. So when we start a co-design project, the most important is to define the goals that we want, and really make sure that those are goals and that are not means. And ideally, we should have one or two goals. Try to reduce as much as possible. So ultimately, we won't even go beyond carbon footprint and just say as goal, it must be sustainable and take into account all the planetary boundaries. But this approach has also its limits. So we are engineers. When we develop a product, it's engineering work, and we need so to have goals that are measurable, and this is why we will anyway choose something like carbon footprint or some measurable goals. Today we don't have metrics to take into account the whole sustainability, or at least a metrics that is widely used. And then when we have defined as less as possible goals, we use typically life cycle assessment all the way along the development process. So first from concept, then to design, then also into the industrialization. And we feed this LCA model. So at the beginning, it is very simple because the concept is not there is many unknown. So we take assumption. And we test with this LCA model every decision. So first concept decision to see if I take this or this approach, do I have more or less carbon footprint or other metrics, like some metrics, for example, for biodiversity. And we do this in iteration at every steps of the development process. So starting with concept, also in the design, also in the industrialization. And with this, you have a solid approach where you can really say why, and you don't focus on the mean. So those are the solutions that you will test. Is it good if I use a mechanical, or if I use a reuse strategy where I need to sanitize at some point? And with this, you can really focus on the goals and don't lock down into a technology, into an approach which in the end will not serve the ultimate goal.
Okay, good. I mean, could we try to list for our listeners like solid principles that we could implement in our design or development process, such as maybe optimize your product, don't over engineer, try to use the material with the least environmental footprint that still does fulfill all your requirements. Try to reduce the variety of materials in order to make it more recyclable. Do you have anything to add to that list? Because this is usually the one that I pick. I mean, I have a few more.
Yeah. So yeah, we start like this. So usually challenge the function. Do I really need to have this function? So design for as little. Really focus on what is needed. Don't add too much. No gold plating. So do I really need this function? This is the first question. And then what performance I really need for this function, especially for electronics. You can save a lot if you accept to have a little bit less performance. Then, of course, for mechanical part, look at the materials. Then also in the mechanical design, try to optimize the geometry so that we have as less material as possible. Very often you have material in areas where you don't have stress, and this you can just remove. Challenge also on the look at the logistics. So logistic, of course, you can decide to work with one or the other company, but you can also think about if you think it well, you see that your design decision may have also an impact on the logistic. For example, if I choose a component that is very difficult to procure, then maybe I will have more logistic that rely more on aircraft, on air freight, and this will have an impact on the carbon footprint. Also, there's aspect of modularity. So if I expect to upgrade my product, or if I expect to can I improve my product for repairability, the aspects of energy consumption, of course. This is something that, especially if I have energy intensive product, the aspect of the recyclability and also the aspect of the maintenance. So does it make sense, for example, for a complex medical instrument that needs to be recalibrated? Should I implement a remote service features? But this means also that it will add up on consumption, maybe more connectivity. This will also add up material and some electronics. So to balance this and really make an educated decision whether it's better to let the technician travel a little bit more or it's better to add some hardware to allow the remote service. So this is one other aspect. So typically we have a list of 9 of those eco-design principle, or can call it also checklist.
Okay, thank you very much for those insights. This is very, very valuable for our listeners. I heard your talk on the Swiss MedTech Day about this eco-design topic, and you mentioned a case where a medical product had to be taken care of during the year, and how the service intervals can impact the sustainability of the whole device. Can you elaborate on that case? Because I think this was very insightful. It shows that we really have a system, a complex system that we have to look into, and that we can measure and look at different cases and see where the sustainability can be impacted the most. Do you enjoy the podcast? Then subscribe and rate it on your platform. And join the discussion on LinkedIn. Your feedback and comments help us improve the podcast and bring relevant topics to you. Let's form a better world with plastics.
Yeah, so it's the case that you refer to is a complex instrument that needs to be recalibrated and serviced. So some parts need to be changed every year, and this means that in average we have the technician that needs to travel, take a plane for about a few thousand kilometers per year. So these have a large impact on so this is a major contribution to the carbon footprint in the use phase of this instrument. And what we have found is that with adding some features, so in terms of electronics and in terms of function, we could save some of those travel, at least reduce from once a year to twice a year, to allow only minimally trained people that are available on site of this instrument to perform also some of the calibrations. And in that case, we saw that we could reduce something like 20 to 30%. I don't remember exactly the number, but of that order, the carbon footprint of the product. But this is no general statement. I would not say again, remote service is the best. Everybody should, and in every product we should implement remote service. This needs to be checked case by case. The trade-off between more material, more electricity consumption, and but less travel.
Yeah, this reminds me of another case. There was, I think, coffee machines of Thermoplan, and they did an analysis of their coffee machines, and the functional unit is, of course, one coffee. And then, depending on how much you use the coffee machine, so if the coffee machine is a Starbucks machine or a machine at your home, you have vastly different amounts of coffee that you produce with the machine. And they saw that with certain machines, so the high volume machines, the biggest impact is, of course, coffee and the milk that goes into the coffee, but also use time energy. And use time energy was bigger than the impact of the coffee machine or the materials that went into the coffee machine. So they decided, okay, let's just optimize the machine for energy efficiency. And if it gets heavier or if it has more impact in production, so be it, because the system in use will have the lower environmental impact overall because you made the machine very energy efficient. And there is where the highest impact lies. And then you have the single-use medical devices that have the most impact, or just straight comes from the material that you use. And so products can be vastly different where the biggest lever is on the ecology. Or can you comment on that?
Yeah, it's so the eco design best practice we would always recommend to don't take any general statement, and when you So in eco design, you will not look, or in LCA, you don't look at the product, you look at the functional unit. So functional unit is not only the product, it's the product with how it is used. And this is important because, and this is what is also very interesting in eco design and very a bit challenging, is that you need, if you want to optimize your product, you need really to use at the use case. This is very important. And maybe you will end up implementing really eco design. You will maybe end up with more products or more product variety because you need to adapt to one or the other use case.
Mhm. Okay, so it's always best to look at your functional unit, what your product should do, and then you can compare vastly different products. I think a very good example of a functional unit is, I mean, coffee is one, but I like the functional unit dry hands. This is, you can compare like paper towels versus like something like an Dyson Airblade. So these machines that blow on your hands, and then you can compare vastly different techniques or products because they have the same purpose, namely to clean, to dry your hands, and then you can make the comparison. So that is a very good example to bring the point home. What is a functional unit?
Exactly. So exactly, this is a very good example. I like this example. And in the end, eco design is you really, and this is also the goal in the end of the design, not only eco design, to really look. The goal is not to deliver a product. The goal is to deliver a service to a user,
A benefit.
and how you do it the best way. Yeah,
Yes.
exactly, a benefit.
Yes, exactly. Either deliver a benefit or alleviate the pain. That's the two things that the product can do. Either it saves me pain or it gives me something I like.
Yeah, I can totally agree on that.
Yeah, coffee is like both. Saves me the pain from being tired and gives me the benefit of being of enjoying the coffee. Okay, so you're from Helbling Technic. You could probably a bit elaborate on what you do, what your services are, and what solutions you provide. Just a quick introduction.
Sure. So Helbling is an engineering and consulting firm, and I'm belonging to the part Helbling Technique. And at Helbling Technique, so we mostly focus on products and especially the development of product. And our team, so sustainability engineering, we here focus mainly on eco design and sustainability assessment of products. And so we have typically 6 typical type of projects. So the first along the development process is how we translate the corporate sustainability strategy, so at company level, into a product sustainability strategy. Because here we figure out that it can be a challenge for many companies to really understand and define what to do at product level when a company strategy has been defined. Mm-hmm. So this is one. Second is what we call concept for sustainability. So we often have companies that come to us and say, okay, I have today this product and I want the next generation to be more sustainable. And here we looked at, in a very holistic way, at different approach, different solution, and always try as much as possible to quantify the benefits of those different solutions to then make a concept that is more sustainable. A third one is eco design, what we simply call eco design. It's the support of development team along the whole development process. Another one, fourth one, is sustainability due diligence. And here, typically when a company comes to us and say, okay, now I have this product, already existing, and I want to change the heating technology, or I want to change the material because I think it is more sustainable. And here we really check, do what we call a sustainability due diligence to check if this is at all more sustainable, so based on metrics. If this is also aligned with the company strategy, and also just to make sure that then there is a communication, a sound communication, and that there is no risk of greenwashing. And the two last one are what we call sustainability in production. Here we help our clients to find OEMs or suppliers that are optimized in terms of sustainability. And the third one is what we call environmental declaration and scope 3 emissions. Here, it's when the product is here, and we help to generate the data for typically the type 3 or type 2 environmental declaration, or for the reporting.
Okay, thank you for the introduction. So I think we come to the last question. What advice would you want to give to the listeners regarding eco design?
Yeah, so to build, it is important when you want to tackle the sustainability of your product, to build on that, on the corporate sustainability strategy and on the coming regulation, because otherwise you will just go with the wind and not end up with a solid solution and a solid roadmap for your product sustainability. And also, very important, always build your product sustainability strategy and roadmap on facts and figures, and no on emotions, because emotions will last maybe 1 year, but then you will end up to invest a lot in maybe the wrong directions, or the directions that will not last many years. So if you build on corporate sustainability strategy, on coming regulation, on fact and figures, then you have really a solid foundation on which you can build a marketing story. And you should not do the other way around, starting with the marketing story and find what you can do. And I don't want to say marketing story is not important. This is very much important, because you need, I mean, it's an effort. It's an effort to invest into sustainability, and you need somehow to capitalize on it, and you need somehow to use it to get a competitive advantage. But it just need to not go the other way around, starting for marketing. And then my second advice is would be to always try to quantify things regarding the product sustainability, and aim for comprehensiveness. So when you need to look at the product sustainability, you need to look at the whole life cycle. So this is what you do in a correct life cycle assessment. But even in life cycle assessment, you can do a cradle to gate, and you just see one portion of this life cycle. So this is important, to have this life cycle thinking. This is even more important than trying to be very much accurate, because when you do a life cycle assessment or a sustainability assessment, there is so much assumption that you need to do that it doesn't make no point, and you will lose yourself into detail if you try to have the second digit after the point to get the carbon footprint. I mean, in today, with the data that we have, you just aim for the order of magnitude just to guide your decision. I mean, in the end, you need to remember, eco design is not about knowing your carbon footprint. It's about taking a design decision, considering the carbon footprint.
Mm-hmm. Okay, I mean, I couldn't have said it better. Facts and figures, and look at your whole life cycle. Look at your system, and try to let the decisions be guided and informed by your assessment, and not be the whole thing. Because on the other hand, as you said, you also need to make money. Sustainability, maybe a point that I just want to make, is sustainability is used in usual language that we hear just as synonym for ecology, but it's not. Sustainability has social aspects, has an ecological aspect, it has one, and an economic aspect. And all three have to be together to be really sustainable. And people talk about sustainability as if it was ecology. What people are actually talking about is ecology and not sustainability. And you have to take into account the companies need to make money, and that they also have to fulfill the social contract that they need to fulfill. And I think this is very important, and a very important point, that sustainability is more than just ecology.
Yeah, thank you for mentioning that. Indeed, that is very important. Yeah.
Okay, good. So thank you very much for being in the podcast. Any last words from you?
Yeah, I think maybe first, thank you very much, Lucas. That was a very interesting discussion to my point of view. And I would really encourage, so you should not see, I mean, for any companies that listen to us, it's you should not see eco-design and LCA like a burden. And you can think that your product, that you can not do anything on your product. What I saw is that we always started with companies with a very simple LCA. Just invest a few hours or even an hour doing first calculation. And then as soon as you have that, in all the case where someone told me, no, we cannot do anything with our product after doing a very rough LCA, then the inspiration come and you see what you can do. So I would recommend just to anybody, just do this exercise. And in most cases, it's also bring the inspiration.
Okay, thank you very much. This was Jonathan Demierre from Helbling Technik. And until the next time. Still looking for more in regards to plastics and medical technology? Visit our website www.gradical.ch and inform yourself on the services of Gradical. You can also check out our market report on medical grade plastics on www.medicalgradeplastics.de. Or you attend a training regarding material compliance at CATS or at SKZ. And of course, don't forget to rate and subscribe our podcast wherever you get your podcast. Let's form a better world with plastics.